Hello everyone, this is our next question for nodal analysis. So here we find current in 6 ohm resistor by using nodal analysis. If you see this circuit, in this circuit there are two voltage sources, 10 volt source and 5 volt source, which are connected between the nodes but does not contain any branch resistance. So let's see the solution. So here first we define nodes in this circuit. In this circuit there are total 4 nodes. This is node 1, node 2, node 3 and node 4. Now here we will assume one node as a reference node. If you select node 4 as a reference node, then node 1 voltage we can define by this 10 volt source, and node 2 and node 3 become supernode for this circuit, and we will get the equation by 5 volt source. Then if we select either node 2 or node 3, any one node as a reference node, if you select 3 as a reference node, then node 2 voltage we can define by this 5 volt, and node 1 and node 4 become supernode for this circuit. So here select any one node as a reference node. Here we select node 4 as a reference node, that is at 0 volt, node 1 at V1 volt, node 2 at V2 volt and node 3 at V3 volt. Now at node 1 we define branch currents. This is I1, I2 and I3. At node 2, I2 is already defined. This is our branch current I4 and this is I5. At node 3, I3 and I5 already defined. So here next branch current is I6. Now we define equations for source voltages. First we select 10 volt voltage source. So here this is our 10 volt voltage source which is connected between node 1 and node 4. Positive terminal is connected to node 1 and negative terminal is connected to node 4. Node 1 at V1 volt, node 4 at 0 volt, and assuming branch current is from node 4 to node 1. So here this is our assuming branch current, that is I1. So here this terminal is positive and this terminal is negative. According to current direction, you can write 0 from 4 to 1, 0 plus 10 minus V1 is equals to 0. Here we get V1 is equals to 10 volt. Now let's see the other voltage source. This is our 5 volt voltage source. Positive terminal is connected at node 2 and negative terminal is connected at node 3. This is at V2 volt, this is at V3 volt, and now our current direction is node 2 to node 3 is I5. Now write the equation according to current direction, that is V2 minus 5 minus V3 is equals to 0. This is plus terminal, this is minus terminal. So here you can get V2 minus V3 is equals to 5. We will write the equation according to current direction. So now we get two equations from the source voltages. Now apply KCL for getting the solution. here we have to find current in 6 ohm resistor. So for 6 ohm resistor we will calculate node voltage V3. So we will apply KCL at this node 3 and node 2 for getting the solution, and node 1 voltage V1 node voltage we already calculated at 10 volt. So now apply KCL at node 2. First apply KCL at node 2. At node 2, I2 is incoming current, I4 and I5 are outgoing current. So here I2 is equals to I4 plus I4. So let's see the equations. I2 is equals to V1 is initial voltage from node 1 to node 2 minus V2 is final voltage divided by branch resistance 2. Now you can write I4. I4 is from node 2 to node 4, that is V2 minus 0 divided by branch resistance 8. So we put all these values. So here V1 minus V2 divided by 2, that is V2 by 8 plus I5. So let's take LCM. This is 8 V2 plus 8 I5. So here you can write this is 2 4s are 8, so you can write V1 minus V2 into 4 is equals to V2 plus 8I5. So you can solve this equation. This is 4V1 minus 4V2 is equals to V2 plus 8I5. Now you can write 4V1 minus 5V2 is equals to 8I5. You can write 4V1 minus 8I5 is equals to 5V2. So here V1 is 10 volt, that is 40 is equals to 5V2 plus 8I5. So this is our first equation. Now KCL at node 3. At node 3, I3 and I5s are incoming current. So here I3 plus I5 and I6 is outgoing. So here you can write I3 I3 is flowing from node 1 to node 3, that is V1 minus V3 divided by 4, and I6 is flowing from node 3 to node 4. Node 3 is V3 minus node 4 voltage is 0 volt divided by 6 ohm. So put all these values, that is V1 minus V3 divided by 4 plus I5 is equals to I6 is V3 divided by 6. So take LCM, that is V1 minus V3 plus 4I5 equals to V3 divided by 6, 4, 2 3s are 6, this is 3V1 minus 3V3 plus 3 4s are 12I5 12I5 is equals to 2V3. So here you can say 3V1 is equals to 5V3 minus 12I5. V1 is 10 volt, so here you can get 5V3 minus 12I5 is equals to, this is our equation 2. So here first equation is, so our first equation is 5V2 plus 8I5 is equals to 40, and second equation is 5V3 minus 12I5 is equals to 30. So here we will calculate V3. So for getting the 6 ohm resistance, so we put the value of V2 in terms of V3. So let's see the value here. The value of V2 is equals to V3 plus 5. So put all the value of V2. This is V3 plus 5 plus 8I5 is equals to 40. Now you get 5V3 plus 8I5 is equals to 5 5s are 25. 40 minus 25 is equals to 15. So this is our equation 1 in terms of V3, and our equation 2 is 5V3 minus 12I5 is equals to 30. So solve these two equations, equation 1 and equation 2. So here we will get V3 and V5. If you solve these equations, then you will get V3 is equals to 21 by 5 volt and I5 is equals to minus 3 by 4 amp. Now current in 6 ohm resistor for our answer. Current in 6 ohm, that is I6 is equals to V3 divided by 6. V3 is 21 by 5 divided by 6. So here 3 2s are 6, 3 7s are 21. So this is 7 by 10 ampere. So 5 2s are 10. This current is 7 by 10 ampere, or you can write 0.7 ampere. So this is our answer for current in 6 ohm resistor. So this is our answer. So here you will see the solution of this circuit, in which we can define any one node as a reference node. Thank you. Thank you for watching the concept. Please like and subscribe my channel.